Okay, let's talk about section 260 and more of the algebraic proof. All right, you'll notice that we're talking a lot about algebra here, but as you get higher and higher in mathematics, whether it be algebra 2, pre-calculus, or if you go to calculus, even calculus or AP stats down the road, any of those courses, trigonometry, they all involve algebra. Algebra is the foundation for all math that you're going to be using, not just here, but anywhere else you go beyond here. So we gotta get algebra. Even though it's geometry class, we're going to be using a lot of algebra. All right. Last time we talked about the properties. We talked about the addition property of equality. Now I'm going to highlight them for you real quick, just because I can. Addition property of equality, subtraction property of equality, multiplication property of equality, division property of equality. You see how they each work. Add 2, subtract 4, multiply by 4, divide by 8. Then reflexive means anything's going to be equal to itself. Symmetric means that in order could be switched around. Transitive means if two items equal a third item. So for example, x equals 3 and 3 also equals y, then that means that x also equals y. And then of course you got the division, or excuse me, the distributive, I can't get it out right. Distributive property says, for example, 3 times x plus 4 equals 3x plus 3 times 4, or 3x plus 17. Not 17, 12. Oops. I don't even know where I got 17. 17 is a prime number. That was an example of a brain fart there on my part, folks. Even there, I can't even get the words right out. So, all right, let's just move on. Okay. Now, let's review a little bit. This is from last time. This is our homework quiz. We have our given. We always start with our given. Sometimes a given's a diagram, but in most cases, it's a statement like this, and this is our given. Sometimes given takes up multiple steps of proof, and that's okay. You'll see that more as we get into chapter 4, especially when we're dealing with triangle proofs. I love doing triangle proofs. You probably may struggle with them at first, but I think you get the hang of them once you get the hang of them. All right. First things first, our statement is the given. Our first statement is the given. Then we got to get rid of this 8. So we have to add 8 to both the left and the right. By adding 8, that is the addition property of equality. And by the way, I don't care if you abbreviate this or not, or write out the addition property of equality. I usually abbreviate it when I'm doing my notes here. So, all right. And then, of course, you combine the like terms together, you simplify. Next step, we got to get rid of the 4. So we multiply by 4. That is the multiplication property of equality. And then, of course, you combine the like terms together, that's simplify. And then we got 3. We're left with 3x minus 1 equals 32. So I got to get rid of the 1 by adding 1. So I'm going to do that. Let me add 1 plus 1. That is once again, the addition property of equality. Now, here's a question. Can you use the same reason in multiple steps of a proof? The answer is yes. As you see, we're using simplify multiple times. We can use the addition property of equality multiple times. That is perfectly fine. You can use it as many times as you have to. And then we got simplify. Then divide by 3, and that there is an example of the division property of equality. And then you've got simplify. Now these like APOE, DPOE, and they're not going to be in every problem, but they're in these algebra related problems that you've dealt with. Now, look at this again. You did this last year. You probably did it pre-algebra. You have done this before. You've done all these steps. You know how to do the algebra. All you're doing here is giving a reason for it. That's all you're doing. So that was your homework quiz. Now, we're going to get to some real fun stuff here. Before we do that, let's go back to this previous slide. Notice a postulate is a statement that cannot be proven, so we assume it to be true. I'm going to highlight that with yellow. A postulate is a statement that cannot be proven, and an axiom is another word for postulate. So those are two key words you need to know. Postulate and axiom. Those cannot be proven. A theorem, I think I mentioned it in the previous, in section 2.5, but we didn't have it listed on there. A theorem is a statement that can be proven using using postulates or previously proven theorems. So we can prove a theorem by using postulates that we've already covered and or theorems that have already been proven. All right. Now, here's the thing. In this particular proof, we're not actually verbally a given. We have the diagram. So I'm just going to say use, or better yet, refer to diagram. And that reason is the given. That's our given. Okay, so here's what I'm going to do. I am trying to prove that angle 1 is congruent to angle 3. Basically, here's what I'm trying to do. I'm trying to prove the vertical angle theorem. We've talked about vertical angles being congruent. Now I'm going to prove it. I'm going to prove it using what I already know. So I'm going to go through this with you step by step. And of course, you know, you can always ask me questions via email or just ask me in class. I'll be happy to help you. All right, so here's one thing we know. We know that, and I'm going to highlight this, angle 1 and angle 2. The measure of angle 1 plus the measure of angle 2 equals 180. Why? Definition of supplementary. The definition of supplementary angles. All right. So by definition of supplementary, angle 1 and angle 2 add up to 180, because if you look, they form a line. Now, the same thing goes with angles 2 and 3. Now, notice I'm using the same angle twice. There's a reason why, and I'll show you in just a moment. Okay, so we know that the measure of angle 2 plus the measure of angle 3 equals 180, and that is also by the definition of supplementary. Now, I do this to show that it's the exact same reason, so I just go ahead and I put them in I just put the quotations there to show that it's the same thing again. All right. Now, I want to prove that angle 1 and angle 3 are congruent. But before I do that, I got to do some substitution. I got to work with these. Okay. So, here's what I do know. I know that they both equal 180. Since they both equal 180, I can set them equal to each other. So I can write the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. This is an example of a geometric proof. And you'll be doing more of this stuff as the semester goes on, especially in chapter 4. We're doing a lot of, when we do this, we're doing triangles and other shapes of that. So I have two reasons why. First, I can say transitive property, or I can say substitution. I can say substitution. Either one would work. All right. Now, I want you to look at this. Let's look at what they have in common. What they have in common is right here. They both have angle 2. So I can subtract angle 2 from both sides. I can say the measure, angle 1 plus the measure of angle 2 minus the measure of angle 2 equals the measure of angle 2 minus the measure of angle 2 plus the measure of angle 3. I'm going to highlight that so you can see it right there. I'm subtracting the measure of angle. No, I'm not subtracting angle 2. I'm subtracting its measure. Anytime I have a numeric value, I have to say the measure of that angle. And that, by the way, when you subtract by the same component on both the left and the right, is an example of the subtraction property of equality, or SPOE. All right. Now, once I've done that, I now have that the measure of angle 1 equals the measure of angle 3, and that is by simplify. Okay. I'm asked to prove that angle 1 is congruent to angle 3. All I've proven is that their measures are equal. But once their measures are equal, I can then state that the angles are congruent. So my last step here is to state that angle 1 is congruent to angle 3. But the reason is what was discussed in section 2.5 is by definition. Let me rewrite that. Hold on. Sometimes it doesn't always cooperate, so. Definition of congruence. All right. So I first stated that their measures are equal. Once I state that their measures are equal, by definition of congruence, I can state that the angles are congruent, which is exactly what I was trying to prove here. And I've done that. That is the vertical angles theorem. Vertical angles are congruent. We've proven it. You can use it anytime now. As a matter of fact, you can use it in future proofs, which we're not going to do that right now. But I'm going to go ahead and stop this right here because I'm running short on time and I want to be able to continue this. We will continue this in part 2